So what do we do to evaluate improper integrals? Again, an improper integral is whenever we have infinity or negative infinity as one or both of our limits of integration. Well, all you're going to do is you're going to replace that infinite limit, that infinity or negative infinity, with a variable. Just use a letter. I usually use A's and B's. That's what our book uses. It says then you integrate it with that letter. So you're going to be plugging in one letter and one number. Or I guess technically it could be both letters, but I'll show you how to do that shortly. Okay, it says evaluate the limit as the variable approaches the infinite limit. So what this means is we're going to take the limit as we approach infinity or negative infinity instead. So let's take a look at this. It says if f is continuous on an interval from a to infinity, then the integral from a to infinity, notice this is an improper integral because we have that infinity up there, is equal to the limit as b approaches infinity of a to b of f of x dx. So let me kind of cross this out to make this look a little more like something that you could use. So a here would be a number. A would be a number like, I don't know, how about if you wanted to integrate this from 5 to infinity? Well, what are you going to do? What you're going to do is write it as the integral from 5 to b, literally the letter b, and you're going to evaluate that definite integral just like you would. Do the indefinite integral, plug in b, plug in 5. After you've evaluated that integral, you're going to have an answer that has b's in it and numbers in it. You're going to take the limit as b goes to infinity. So do the integration first, and then take the limit as b goes to infinity. Likewise, what if it was something like negative infinity to, I don't know, how about 0? Doesn't really matter. Well, if I had negative infinity to 0, what I would do is the integral from a to 0, and I would let a approach negative infinity. So integrate from a to 0, literally using the letter a. You're going to get an answer that has a's and numbers. That's great, that's fine. And then you take the limit as a approaches negative infinity of that. What do you do if you have both limits are infinite, so you have a negative infinity and an infinity? Well, we need to use one of the rules that we know where you could break it up. So for instance, you might want to do the integral from negative infinity to, I'll just pick 0 again, because that's always a good number. But then you would also need to integrate from 0 to infinity. So on the first one, you would have to do from a to 0, and then take the limit as a goes to negative infinity. And on the second one, you'd have to do 0 to b, and take the limit as b goes to infinity. So I know this sounds a little complicated when you're just looking at this, so I wanted to work through an example with you. And by the way, it says in the first two cases, if the limit exists, then the improper integral converges. So we call it converges if you get a number, a finite number. It says otherwise the improper integral diverges. That would be if you get something like infinity or negative infinity. So converges is when you get a number, diverges is when you get an infinity or negative infinity. It says... Okay, let's just look at the example. It says, for example, consider the integral from 1 to infinity of 1 over x squared dx. So again, we're going to find the integral from 1 over x squared dx. So in the real picture, I'm wanting to find all of this area, the entire area as it goes out to infinity. But how am I going to do it? What I'm going to do is I'm going to rewrite this integral as the limit as b goes to infinity of the integral from 1 to b of 1 over x squared dx. That's how I'm going to do it, is rewrite that integral. And so the idea is I'm finding this area as it goes to b, but then b is going out towards infinity. So I'm finding the area as it approaches infinity, okay? So what do you do first? Well, do the integral just like you would do the integral. So what's the integral of 1 over, or from 1 to b of 1 over x squared dx? Well, again, 1 over x squared is the same thing as x to the negative 2. And the integral of x to the negative 2 would be x to the negative 1 over negative 1. X to the negative 1 over negative 1 simplifies to be negative 1 over x. But we still need to plug in our limits of integration, the 1 and the b. You plug in the b first, and then you plug in the 1. And I end up, when I simplify, if I did the integral of 1 to b of 1 over x squared, I end up, the definite integral, I would end up with 1 minus 1 over b. So numbers and letters, and that's a good thing. So what's the last thing I need to do? All I need to do is evaluate the limit as b goes to infinity of that answer. So if I do the limit as b goes to infinity of 1 minus 1 over b, remember that 1 over b, since it's bottom heavy, and the bottom is going to infinity, this term right here would go to 0. So I'd have 1 minus 0, which is just 1. So it does converge to a number, and the answer is 1. Again, what did we do? Replace that infinity or negative infinity with a letter, integrate it with the letter, get your answer, which is going to have numbers and letters, and then simply take the limit as that letter goes to infinity or negative infinity. Go to the next page for some more examples.